All right. Cool. Office hours. These are the 3 questions I have so far. Does anyone else have any other questions they want to try to get to in this hour? All right. Let me know if you have any as we go. Cool. So, who wanted to talk about this module? You, sir. Cool. Did you have any questions about it, or did you just want to go over it in general?
Yeah, well, I went over the tutorial, the YouTube video, and I did everything the guy asked me to do, but I sort of am confused about like why we are doing it in the first place. Like, why do we have to do this setup?
Sure. Yeah. So you don't have to. This is just something for you to be aware of because the world of JavaScript is in kind of like a weird flux. It's actually kind of always been in some sense, but basically most languages like a Python or a Ruby or something like that are going to be in the version that you are executing, you have control over. So if you want to make an application using Ruby 2 or Ruby 2.3 or 2.3.2 or 3.1 or whatever, you have control over that. We don't get so much control in the JavaScript world because we create content that is not executed in an environment that we have control over, which is the browser, right? So I create a web page, I write some JavaScript for it. It's going to be executed in anyone's browser who asks for that web page, right? So jared.com, I wish I owned it. You go there in Chrome on my MacBook, it's going to be running a different version of JavaScript than if you're running Internet Explorer 7 on, you know, some bank teller's free time break workstation, right? So there's different execution environments, and so we have a moving target in terms of what features of the language we have available to us. Not only features of the language JavaScript itself, but then since we're talking about the browser, also features of those browsers. Maybe it has background CSS gradients, maybe it doesn't, right? So I'm not really talking about browsers in terms of those features like rendering differences and CSS differences, but this party, like it's ES 2017, is just showing you that, is trying to make you aware of the fact that we have different features of JavaScript that are available in different environments. And so Babel, which is what this, and webpack are tools that we might use to enable future features to be usable in older versions of JavaScript. So for example, in a newer version of JavaScript, when we write functions, right, every version of JavaScript supports this kind of function, right? Newer versions of JavaScript support this kind of function. So let's just make a simpler function, right? Or even smaller, right? So there are this is one example of a newer feature in the language. This ability to do arrow functions instead of functions, right? That's a newer feature. It happens to be supported in the latest version of Chrome and recent versions of Chrome, but it's not supported in older versions of browsers, right? So if we're writing code and we want to use these new features, the safest way to use them when we're writing code that's executed in an unknown environment, like the web, we're going to take this code and we're actually going to transpile it. We're going to convert it into old JavaScript code that works the same way. And that's what something like Babel is going to do. You don't necessarily need to worry about this very much in phase 1 or even phase 2, but as we start to build applications where we want them to work in as many places as possible and we want them to be as reliable as possible, we're probably going to take advantage of one of these transpilers to take our code that works in the newer places and convert it into code that should work in all places. So this module is just to help you be aware of that concept in the JavaScript world. If you want to know more about it, you can Google Babel.js. These folks have been writing that transpiler, or one of those transpilers. So these folks have written the code to look at JavaScript like this and convert it to the older version, to a compatible older version. So you might see, here's an example. This is one of those arrow functions. Well, why did it go away? Oh, because I clicked on it? So here we're taking one of those arrow functions, and it's now converting it. So like even that, like star star, isn't supported in all versions of browsers. So it converted it to math.power, right? So this is just something to be aware of. Now, when you're going through the exercises in phase 1 and phase 2, where most of that stuff is going to be, some of the stuff in phase 2 is in the browser, and we've got some browser stuff. But if you're just running Node, as long as you're running a recent version of Node, all the stuff you really care about should work, and that syntax should be available to you. There's some stuff that's not, like import and export, and there's some other things. If you want to drill down into those features, script feature compatibility. So there's a couple of places that are trying to kind of compile these together. This is an example of some features that have been broken down into itemized things, like arrow functions is a feature, let and const are individual features, and they show you like which compilers and polyfills and which desktop browsers and which server runtimes support these features. So if you ever want to say, okay, I don't want to transpile, I just want to make sure that my code is only running that I'm only using the features that my code is going to have available to it, you might look at a table like this and come say, okay, I'm making an app that's only for Firefox 5.5, right? Probably never going to be true, but let's say it was, then you could come in here and see that you could use all these features. But if you were going to try to use Internet Explorer 11, it doesn't support any of those features, so we'd have to use transpiling to get our newer code to work in this older environment. So Babel is a tool that will do that for you. And then Webpack is a tool that will use Babel to do a second stage of code compilation to package things up so that they work in the browser for better for other reasons. And Webpack's on the list, so we'll talk about that too. Yes.
So does Babel like spit out a different file or change the things and spit out a different file that you then serve?
Exactly. So oh man, this is actually going to be a pain to set up. Let me just see if I can copy something from here. So Babel is sort of a general tool, and then it's a general transpiling tool. And so then you install these things they call presets, which are basically plugins for this tool that support different features. So they used to call them, so some more background to this is that like we had ES5 forever, and then ES6 came out, and it was like there's a body of folks who decide what is going to be in the new version of the language, and they come out with a new spec, and then browsers try to implement that. And so there's this delay of like, okay, here's the new version of JS, Internet Explorer, Firefox, Chrome, everybody please implement these features, and they slowly kind of trickle in, right? So I think what they're doing now is they're just doing like yearly releases or even sub-yearly releases where they're just like, and they're kind of itemizing everything by feature, I assume to try to make it easier for browsers to sort of a la carte pull in these features. I bet it's a hot mess, but this preset env I think is just their latest thing, and they want me to put it here. So this is like a configuration file. Great. So now usually what you do is you make two directories, a source directory and a build. Sometimes this is called dist for distribution. I'll call it build. It's irrelevant what you call these. And then if I put a file in source called great. And then I do Babel source-d build. export default. There we go. It is going to go through all the files in the source directory and copy them over to the build directory and transpile them to an older version of the code. So here's the source version, and then here is the built version. So it changes quite a bit. This is some internal stuff. This is really the difference, right? It's almost the same, except it's using exports default, right? So we could go into more about how this transpiling works and what does new code turn into to make it work, but that would be a talk for a different time. So that's the gist of Babel there. Cool. It dovetails pretty well into webpack. So webpack is sorry, any more questions about Babel or transpiling? Cool. Sal, is that a question? No. So cool. So Babel is a build tool in some sense. We take our code that's written in some way, and when we're ready to ship that code to wherever it's supposed to go, we build it. We have this step where we take our source code and we turn it into this actual code that's going to be executed, right? So there's this sort of work that needs to be done. Webpack is another build tool where picture we're building a Facebook or another large website where there's literally probably hundreds of thousands of lines of JavaScript that need to be dealt with and put into different places and run at different times, right? So because of some optimization stuff about how we load assets in the web browser, we're gonna want to load as few JavaScript and CSS and other assets as possible. We don't want an HTML page with 75 JavaScript files that we have to load, because we have to do an HTTP request for each one of those, and the handshake, just making that phone call basically, takes time to dial the number, is the metaphor here, right? So it takes time to say, hey, give me this file, not to mention just the time it takes getting the file back, right? So we don't want to ask for too many assets. So to optimize our web page, we're going to take all those assets, the CSS, and we're going to squish them all into one file. We're going to concatenate them together. JavaScript, we're going to do the same. We're going to take all of our JavaScript files and we're going to smush them into one file. And so it's actually more complicated than just taking all those files and putting them one after the other and just straight concatenating them. We want them to interact in certain ways. We want them to have access to each other in terms of JavaScript, right? So we'll use something like Webpack, which will allow us to have multiple JavaScript and CSS files with one entry point. We'll have one JavaScript file that's going to say, okay, go require these 3 files. And those 3 files are going to go require 27 other files, right? And it's going to build this tree of dependencies. So we might have an assets directory with 200 JavaScript files. 180 of them are currently being used because they're being required somewhere in that tree. And Webpack's job is to go look at that initial file, see what it's requiring, go to those files, see what they're requiring, and walk down that tree and collect all them files and squish them all together in a way that they still work, in a way that the require statements still actually get you the thing that you wanted, even though you're not actually doing anything like a require in Node. You're not reading something off a file system. It's all in the same file. It's all defined in one big JavaScript object, but it still works the way you wrote it. And so that's the gist of what Webpack does, is it packages up your many JavaScript assets into one or maybe 2 JavaScript and CSS assets, so that you can have a more optimized web page.
Does it do that at the time of the request, or like?
Oh man, that would be really expensive to do that every request, right? Because remember, our websites are going to be getting millions of requests a second, probably, right? Depending on what we're working on, right? So this is another part of the build process. So where this fits is we write our code in development, we test it, we make sure it works locally, and then we're going to push that up to GitHub, maybe on a branch, right? And then that branch, I'm describing my ideal development flow here, right? So then that branch is going to run the tests for our application. We're going to make sure that everything else is still working and nothing's broken, right? And then that thing is going to get pushed to, when we're ready to deploy that thing, we're going to push that new version of the source code up to wherever we're deployed in the cloud. Let's say Heroku or Amazon or DigitalOcean, right? We're going to push that new version of the code. Our actual source file, our build directory doesn't exist yet, right? We're still talking about code written in ES6 or ES 2017, right? That source code gets pushed up to one of the machines in the cloud, and we start the build process, where we in the production environment, we first use Babel to transpile our code to something that works in more environments, and then we use webpack to smash it all together, and we store those files on the disk. And then once we've built our application and it's ready to run, we'll make copies of it, and we'll maybe run 5 or 10 copies of it in the cloud. So that's generally how that deploy process is going to go. So we're going to build once per deploy in an ideal setup. So that stuff, that deploy process concepts, that stuff's going to get covered in phase 3. Phase 2, you're not going to need to be webpacking any of this stuff. We're still just going to be working on just the basics of running code in the latest version of Chrome or the latest version of Firefox. It's going to be phase 3 and 4 where you start to really learn these build tools that help you get maximum compatibility and a bit of optimization.
So when you're building a project, you're going to in your JSON file, for example, you're going to have webpack in there and Babel.
Do you mean the package JSON?
Package JSON, yeah.
Sure.
You're going to have Babel and webpack, but you're not really going to use that.
Those are going to be listed as dev dependencies. Because Babel and the plugins for it and webpack, we don't need that when we run our application in production. So any package that we don't need when we're running live in production, we're going to put as a dev dependency.
And you don't use it at all until you actually are putting it on the road or deploying.
No, you'll use Babel in development and during the build process. Both Babel and webpack will be during your development process as well as during the build just before production. But once we've built our product, or once we've come up with our compiled, transpiled, and concatenated source code, we don't need those tools anymore. So we're going to not install them on all of our production machines because we don't need them. We're just going to install the tools that we need to use in production, like Express or whatever other production necessary plugins we have, or node packages we have.
So it made a lot of sense that you wouldn't compile everything and do all that work until you're on the production servers. I'm a little bit confused about what you're saying, like the other instance that you would be using that.
So we need to run webpack and Babel in development.
Okay.
Because as I'm working on adding features to this application and I'm modifying the application, like I need that JavaScript to get transpiled and then packaged and served to my browser all locally on my laptop so that my app will run as close to production as possible, right? In production, there are no changes to the source code. So we compile once, we ship, and we run. In development, I'm changing code, so recompile. Every time I refresh the page, or maybe every time I edit a file, one of those two, depending on how you have it set up, we need to recompile because the source code files have changed. So there's a different need in development. We need to constantly be recompiling and reconcatenating and rebuilding every time we make a change. But in production, there are no changes. We just compile once and go.
That's what I'm wondering. So it seems like if you're, for example, building a CSS page, you're making constant changes. You wouldn't need to necessarily be running webpack and Babel in that instance because you're making a bunch of changes, and then once you're done with those and you have your CSS close to what it should look like on your page, then you want to run those and like actually minify stuff.
No, it's not about minification so much. We would only minify in the production build. So there's some differences between the way we would run these tools in development and in production. We don't need to get into all them details, but as I'm developing feature, I want to be able to come in and make a one-character change and go back to my browser and hit refresh, and I want that change to be implemented. So it's very much going to be, in most environments, set up to be kind of running automatically. Either you're going to start a process that's watching for changes and recompiling automatically, or you're going to have that built into your Express server only in development, so that every time you reload the page, it recompiles before serving back the assets. One of the two is usually a common setup. Because we want to be reloading every time we make our change, right? Cool. Any other questions? Sweet.
Can you add one more thing
Oh,
to
yeah.
the list?
Sure.
Can we talk about the best practices around exporting stuff from the file? So I'll do.
Yeah? Exporting and importing in Node?
Yes, export dot some function, or
Sure.
what's the best way to like
Sure.
export?
We can talk about that. Who had the question about async callbacks
I did.
stuff? You did? Okay. I'm going to do this one first just because it's more relevant to phase one, and then hopefully we'll still have time. We got plenty of time left. Okay. I'll just keep using this thing as an example, but I'm not going to use Babel or anything. I'm just going to put node files in this node module, right? So let's say we have something called, here we'll just to-do list.js, and then we have another thing called, you know, add to-do.js, and we have like a remove to-do.js, right? So we've got a to-do list here, and I'm going to require add to-do, and I'll call this add to-do, right? So here we have a require, and then down below inside of add to-do, we're going to say module.exports equals a function that takes the to-do, add the to-do, right? I'm not going to put any real code in here. So but let me explain what's going on here is we're going to say require add to do, and the thing that is returned, this is a function call, it's not magical. The thing that's returned from this require function is the module exports object itself. Okay. Now by default, if I put nothing in this file, and I'll just log this, we get an empty object. So by default, if you have an empty file, module.exports is going to be an object. It sort of does this for you. So I can just start saying module.exports.foo, right? And that stuff will just get put onto the object that's returned. So if I want to export multiple things, I just use the exports object. I put properties and values on there. And I can come over here and I can, if I wanted just foo here, let's call this something else, whatever, you know, important number, right? Let's say I wanted this thing. I could come over here and I could say, okay, go get the important number by requiring this file and just getting access to that property, right? So this return value here is just going to be whatever this is, and that starts out as an object. But you can replace that with whatever you want, like I did here, where instead of exporting more than one thing, I'm just going to export a single function, in which case add to do is going to be that function that I export. So you can export one thing or multiple things by exporting one object that has properties and values, right? You can only ever export one object, but almost all objects in JavaScript can have additional properties and therefore values added to them. So that way you can get access to importing and exporting more than one thing. A common pattern that you'll see is you'll just see module.export. So let's say this file was just called utilities.js. So we're going to import /utilities, right? And now we want to have things on our utilities called add to do, and then we'll have another one down here called remove to do, and another one here called complete to do, right? So now we're exporting 3 things. So we'll call this utilities, right? And you'll see that I get back an object that has all 3 of these things. So if now I'm exporting more than one thing, I could use, now this is an ES, is a newer feature of JavaScript, but you can do something like, it's called deconstruction, where you can say, this isn't about the require and import process, but this is a common pattern where you'll say, go get all 3 of these things, and what's happening here is require is returning this the exports object. It's an object that we saw before that has these 3 properties on it. But what we're saying is take the add to do property off of this object and put it in the local variable add to do, and so on for these 3 things. So we're able to say we can even do it like this. We're able to say, go get these 3 things from the utilities file by getting back the object that has those properties and then assigning each one of those properties to the same named local variable here. So this is a common pattern that you'll see. Another common pattern that you'll see versus this is you'll just see the definition of these variables. And then at the bottom, you'll see module.exports equals, and you'll just create a new object and give it those properties. It's effectively the same thing. We're just being a little bit more expressive about what exports is. And there's some implications in here, like if complete to do needed to use remove to do, in this case, you'd have access to that variable. In this case, it'd be a little awkward because you'd have to do this, which gets weird, and you probably wouldn't want to do that. So there's some trade-offs here in the style that you're going to use, but they're all effectively just saying, at the end of the day, this file ultimately produces one artifact. It's this object with 3 properties, and that's what you get back when you require it. And you can do whatever you want. You can get it back and just put it in a local variable, or you can use decomposition to pull specific things out of it into local variables in a one-liner. This is the same as if we had done this, right?
So you can do a one-liner from the file that you're exporting from, and at the file you're exporting to. You can do one-liners on both of those, or...
Well, now I'm worried about you having used the phrase one-liner. What do you mean by one-liner? I know I said it just before you did.
Okay, so I consider line 2 to be a one-liner.
Sure. Well, let's talk about this. This is saying I need to go get these 3 utility functions, and I need them available so I can call them, right?
Yes.
I can either do const.utilities, and in my code, come down here and just do utilities add to do, right? Or I can just put those in local variables so that I can use them. I just wanted to illustrate that these are essentially the same thing in terms of how we're requiring an object, right? So ultimately, we're just producing this module exports object. Ultimately, we're just getting back that object with those properties. This is a nice to have. I wanted to show you this because it's a common pattern to do this destructuring, but if that's overcomplicating things, this versus this, right? The module exports object is what you get back from require. That's the core of how this is working. Yes?
So my understanding is that objects, correct me if I'm wrong, don't actually have an order. It's just a pile of key and values.
They don't have an order, yeah.
So when you do the add to do, remove to do, complete to do, how do you know?
It doesn't matter. The order is irrelevant. What this is doing, I'll transpile this for you.
Okay.
So this is one of the new feature.
Yes. It's not installed. Okay. Well, I'm not gonna. Well, maybe this will work actually. Nope. Okay. Let's just go to Babel's website. So it's basically just doing this. It's storing it in essentially a temporary variable.
Okay.
And the order doesn't matter, right? These 3 lines could be put in any order here, but they're just saying put the complete to do property in the complete to do variable. So it's matching property name to variable name. So therefore, you don't need.
Have to be the same name.
It has to be the same name.
Okay.
I think there's a way to not as thing. I think there's a way to do something like that. Yeah, there we go.
Okay.
So again, this is now this is now off topic from the require, import, and export. This is a destructuring feature, which you can read about. But yeah, there's a way to say, put this over here.
Okay, I thought you were just giving any variable or happening to use the same name. But if you want to use that.
Usually this is confusing, and I would not do this. Right? Maybe, but usually we want to keep the names very consistent for easy understanding. So most of the destructuring, I think, would work this way.
Okay.
All right. Does that make sense for import and export? Sweet. Or require and module exports, however we want to say that. Okay, async callback. What's up? Dereferencing is pretty sweet. Yeah. Dereferencing is
by putting it in there, you're letting it know you're looking into the object and getting out those specific keys.
Exactly. Exactly. Yeah. I think destructuring also makes for some very clear like argument definitions for functions as well. Okay, the async callback module in phase 2A. This one?
Yeah.
What's the question?
Well, just in general, I was going through reading.
Mm-hmm.
I just wanted to know if you had any examples that you could give.
Well, I mean, asynchronous JavaScript is sort of like it's a significant cognitive jump, I think, from synchronous JavaScript, right? And as we put together the phase 1 and phase 2 sort of curriculum, we made a split where we thought it would be appropriate to have just everything in phase 1 be synchronous code, and phase 2 you're going to start. That's when you start doing asynchronous code, right? Because it is like an extra cognitive leap to think about. To go from thinking about code that executes from top to bottom, A, B, C, D, to code that's executing in a very different order. So if I can illustrate that, if that would be helpful. So here we have. So I think it's easy to understand synchronous code or how any code is being executed by putting logging statements and seeing the way that they come out, right? So for example, if I say right, we now know by me doing this that we're going to change what's coming out of our logs, right? How's it going to change? How's our? It's going to be ACDE, right? Because I've now moved this into a function. So this is now no longer calling this code. It's just defining a function that could be later called, right? So we could later come down here and call this, and it's going to come out in a different order, right? Okay. That's sort of step 1 to understanding how asynchronous code is working, is that you're going to see code defined and declared, but it isn't necessarily going to be executed at that time, okay? So, and often, if not in all cases, that's going to be done through a mechanism called a callback, okay? So a callback is just a function that is passed to some other function, okay? So for example, if I come in here and I say .for each, and I pass this function a function, right? This is a really important pattern for everyone to see. This pattern right here, where we forget about this part. We call a function, whatever it's called. In this case, it's for each, but we call a function, so we have parens. You cannot call a function unless you have parens. So we're calling. So you got to see these functions. And then in here, this is the arguments. These would be 3 arguments. One is the first argument, right? So I'm putting an inline function in here. So this shape where you see an open paren followed by function that comes down and has a closed curly brace and a closed paren, this is a ridiculously common pattern in this language in JavaScript. So you want to get familiar with seeing that I can call a function by giving it parens and pass it a callback, okay? So for each is going to take this function that I gave it, and whatever the member, this is the array member, we can call it whatever we want. I'll call it n. It's going to log n, right? So this is an example of me not knowing what I'm doing. Let's put a semicolon here. Okay. So this is an example of a callback. So I've defined a function and passed it to for each, but it's calling it right away. So I'd still consider this to be synchronous code. I'm still using a callback, and we're still doing synchronous code. But sometimes when you give a callback to a function, it's going to call it at a later time as opposed to right now. So for example, I can come in here and I can use a function called setTimeout. And setTimeout works by taking some function followed by some number of milliseconds to delay. So I'll just say a whole second. And then in here, I'm going to say console.log. I'll just move D up into here. Okay? And how about we put C here, and I'll just make this BN. There we go. Cool. So we've got A, B, C, D, E. Anyone want to take a guess on how these are going to get logged? What's up?
Whichever one returns first.
Well, none of our functions have a return.
Well, sorry. Whichever one is finished.
What are we going to log first? What's the very first thing we're going to log?
A.
A. Great. What's the second thing we're going to log?
B1.
B1, and then B2, B3. Okay. Then what's the next thing we're going to log?
E.
E.
Yeah.
Yeah. And then the next thing? C. And the next thing? Great. We're getting it. 1 second later, you see the delay? Hanging out, D. Okay? So sometimes functions are going to get called in the future.
So Jared,
Yes.
that set timeout, does it wait a second from when it hits line 11, or does it wait a second until after the rest of the code is completed?
That's a really good question. That's a question about the node, the internals of the JavaScript environment that we're in, and we're talking about it's a question about the JavaScript event loop. And I actually don't know. It's going to be close enough. I know that if we were to log like what time it was here versus what time it was here, it's going to be around a second. It's not going to be perfect. The computer can't, it doesn't have control over itself. No, the node process itself is governed by higher level processes like the Linux kernel that are deciding what instructions actually are sent to the processor at any given time. So it can't guarantee that it's going to be a second. I think it's guaranteeing that it's going to be at least a second, but probably a couple milliseconds over. So if we were going to use this for like some high resolution timing, we may not be able to. We may have to do something different to get that lower level control over when things execute. Sal, you had a question?
So,
Yeah.
I had a comment, but it's okay. I'll start.
Okay. Cool. So does this give a little clarity around asynchronous versus synchronous code? I can show you some more asynchronous examples if you need it.
yeah, I just had a couple people say that callbacks are a little confusing and promises is better.
Well, I would say you can't really, I don't know about can't. Promises are a solution to a problem, a side effect problem that we have with callbacks. But in order to solve that problem, the usage is more complex. And it's more complex in ways that are that make formatting code a little bit easier, and they actually have a lot of benefits, but it's cognitively more expensive, I think. It's more difficult to understand promises than it is callbacks. So I think it's very important that you feel like you have a really healthy understanding of callbacks, so that you can transition to using promises, which uses callbacks plus a bunch of other stuff. So it's sort of, there's more to know. You can't really use promises without understanding that you're also using callbacks, right?
Yeah.
So definitely want to get to the point where you're using callbacks. I've been meaning to add a module for this library. There's a module called async. And it is a way to sort of level up in terms of utility around doing asynchronous code. So you can do things like, I want to run this function with these arguments and then get back in results whatever the return value is this. So this library is a set of helper functions that's going to say, normally you could just map over these, but it's asynchronous, so it'd be kind of a pain to write that map code because you'd have to do 3 different callbacks and you'd have to wait till the last one came back so that you could compile your result. And so this library helps you do that. So this is going to be a way to understand more complex asynchronous code definition. So for example, sometimes you want to say do 4 things in parallel. When those are all done, do 1 thing. These are all asynchronous tasks. Then when that's done, do another thing. And then when that's done, do 5 parallel things, right? So there's a way for us to say, do these steps in parallel and do these steps in series, and then build a complex structure where we're like, read these 5 files, then send an HTTP request, then write something to the database, then read this other file. And these are all asynchronous processes. So if we were to write these with callbacks, it would be like read file. This is all pseudocode, so read file a.txt, then you get a callback with the contents of that file, right? Now we need to read file B, so we're going to come in here, and now the next step is to read file B, and then the next step is to read file C. So this is like contents for A, B, and C, and then we're going to, like, you know, put these in some database with contents A, B, and C, right? And then because everything's callback based, then we have another callback, and you can see each step that we do is in a callback, and we start getting this staircasing effect where all of our code just gets indented further and further inwards, right? So libraries like async will help you write your code where you can do, you know, basically step 1 followed by step 2 followed by, and you can kind of do them more in a vertical. I don't have the syntax memorized, but it basically allows you to avoid this staircasing effect. Promises are made to solve this problem too, where if this was done with promises, it would look something more like this, where instead of all of these callbacks, we would do something like, we'd be able to write our code more like this. So this, again, this is all pseudocode, right? But this should illustrate that, or this is just why promises were created. So you could say, step 1, read a file, then when that's done, read this file, then when that's done, read this file, and you now have this vertical, do this, then do this, then do this, then do this, as opposed to do this, nested callback, do this, nested callback, do this, nested callback, right? So that's the motivation behind why we have libraries like async and promises, is to avoid this regression of, like, if I have a 25-step program, it's indented 25 times, and that's annoying. Yeah.
Can you talk a little bit about how callbacks are dealt with differently by the event loop, which allows them to behave differently on AJAX calls? Does that make sense? Because I've been a little confused about that in the past. That, like, what is inherently different about how they're read and put into the event?
Callbacks aren't the crux of that difference. Callbacks are not treated differently. All a callback is a function that you give some other function that it will maybe call in the future. That's all a callback is. Now, some functions like set timeout, they're written, they're sort of like, they're more powerful functions in the sense that they have, I don't even know, but that's probably not a good way to say it. Some operations that the Node environment or the JavaScript environment in a browser, like a Chrome browser or whatever, so all JavaScript environments, some functions have the ability to do some work that will then later put work back on the event loop. So this is getting now into, like, how the event loop works, but basically JavaScript is constantly running a little bit of code and then waiting and running a little bit more code and then waiting, and it's sort of this loop of work to do, right? And so, for example, set timeout is going to say, wait 1 second and then put work to do on the event loop, which that work is calling this function. So set timeout is a special function in that it has access to do some work that is outside of the event loop. Okay, another example of work that's outside of the event loop, and this is node specific, would be like fs.readFile. If we say, go read this file, and then when you're done, call me back with the contents of that file, it's not that this callback is treated any differently. What you want to know is about the function you're calling. The read file function is not written in JavaScript. It's written in the internals of Node. It's part of Node itself. So it has the ability to say, go talk to the file system and read that file. And when that file comes back, go back to the JavaScript environment that we have and tell it to run this function. So there's a little bit of a bridge here from like what's going on in the code you're writing in JavaScript versus what's going on under the hood in the internals of the JavaScript environment that we're in. And some of those functions can hook into lower level operations that allow it to go do a background task and then come back and report to your JavaScript when it's done. So you can think of these as kind of like scheduling a background job, right? This code is going to go read that file off in the background, and we don't have any visibility into that until our callback gets called. Then we pick up where we left off. So again, if we wanted to read several files, right? This gets called, and then so if this was our file, if this was our whole file, this gets called, and nothing happens. None of these two functions get called. But somewhere in the internals of Node, in the background, we've started reading this file. And once we've gotten that file, then JavaScript picks up and this function gets called. Then we ask Node again, hey, go read this other file. And then we're done. Nothing happens. And then later, our JavaScript environment is told that background job completed and this function gets called. And we can pick up where we left off. So that's how asynchronous steps work. Now, when we're talking about in the browser, because you asked about AJAX calls, and so I'll just put browser code down here. That's exactly like this fs read file function. It's a kind of function that is able to do asynchronous work. So in the browser, we also have set timeout. You can't read files in the browser, so we don't have read file, but we do have like XML HTTP request is one of them. But then we have the newer one, the fetch method. Right? So fetch is a method that'll do an AJAX call, which is just an HTTP request made from a browser. So we'll say do a GET request to /users5.json or something. And when this actually uses promises, so when that's done, give me back that user object. Or this is actually the response to the HTTP request that we just did. So this can be seen as just like a callback here. This isn't how it works, but to explain it, this will go do a background task where it does an HTTP request to the server, waits for that response. That could take milliseconds or several seconds, right? Some amount of time. And so if we're over here in this file and we console log A and we console log C, and in here we console log B, we're going to get AC, some amount of time for that response to happen in the background, for that request to complete, and then B will get logged. So it's not about the callbacks, it's about certain functions have special abilities to do asynchronous operations. Yes?
With regard to reading and writing files, I noticed that in our modules in phase 1, we were using write file sync.
Read file sync and write file sync, yeah, because we're only doing synchronous code in phase 1.
Well, I noticed that when I had written so that it would write a file and then immediately read it, and it turned out that it wasn't quite synchronous.
Like, fascinating. Okay.
It was returning out of the write file sync before the file is actually like saved to the OS or saved to the hard drive.
Interesting find. Okay.
And I was wondering if there was some way around it. I read online where it's something like you said, where it's the way that write file sync is to process internally does go into the HTTP code behind the scenes. And I was wondering if there's a way to.
I don't know.
Promises and all that.
Let's find out. So the question was about using write file sync to write to whatever.txt, and we're going to say hello from Node. And then we're going to just console.log fs read file sync from the same file. Yeah? That's the same?
Right, yeah.
Okay. Node, does Node suck at writing files? Oh, we have to toString it. Hello from Node. Okay, so let's make sure that wasn't from the previous write, and we'll put some different some random number, math.random. I typed too fast. Let's actually log what we're writing first. Let's do this. So it certainly looks like it's working. So I'd be curious to look at
the amount of data that it was writing or something like that.
You think it's the amount of data? Okay.
I don't know exactly what was causing it, but like every time I ran it right after the other, then I looked it up. They're like, "Yep, that's definitely a thing that happens." Right?
Yeah. Well, let's try this. A lot of data. Yeah, I would want to look at your particular situation because it looks like to me that Node is capable of doing that. Actually wait for the write.
Okay.
Yeah. But just to clarify, the reason why y'all are using read file sync and write file sync, swap that, is just to avoid getting into asynchronous code so you can learn about how Node talks to the file system and how file systems work and all that stuff. But like, read file sync and write file sync are to be avoided in the real world. So down the road, this is a bit of a training wheels, I guess. Yeah. Cool. Does that get you what you want to know about async?
Yes, thank you.
Sweet. Any other questions for today?
If we have time, can you go over real quick what the difference in Express apps are between like rendering a response and sending a file? Because it seems like they both like read the HTML and send that response.
Sure. And then you had a question too? Just routing in Express? All right. I will try to do that in 7 minutes. All right. Just installing NodeMon. Oh my God, NodeMon. Why?
You just like sing a song.
NodeMon hold music. We should write that. Okay. So let's see. Localhost 3000. We're getting hello from Express. Okay. So this that I'm doing right now, where I'm just saying response.send. If we want to know more about what Express is doing here, we can use the developer tools. We can go to the network tab and reload the page. Sometimes you want preserve log turned on here. And we'll reload the page. And this illustrates information about the web request that we use to load this page, right? So we did a GET request to the / path on this, and the response headers say text HTML is the content type, the length is 25, and then down over in response we can see, it did not like that. Let's look at the latest one. Here we go. Okay. So again, same thing. We did a GET. We got a 200 back, and it says the content type's HTML, and then we got this string here. So Express's .send method's just going to take a string and say send this back as an HTML response, right? So if we wanted to say like, you know, something like that, we're going to get back HTML. So now you wanted to know the difference between saying render something versus sendFile. Yeah. So render versus sendFile is basically this. Render basically uses. Well, I wouldn't say that. Render is going to do a template compilation step. So we have. I installed EJS. So let me figure out how to set that up, because I can never remember. Yeah, app.set view engine, right, to EJS. And then the way we're going to need a views directory, which exists. Great. And inside the views directory, I'll put a view called homepage.ejs. And so now I have a... So over here I've got an app.js, which is my Express server, and then I've got a views directory which contains templates. And templates are basically utilities that help you generate strings. So in EJS, I'm going to come in here and I'm going to say this is an HTML file, example app within H1, right? And so when I come here, oh, I need to change this. I'm going to say, instead of send, I'm going to say render the homepage template. And now that's going to go, and if we look at the source of this page, it's now rendering this template that I created, right? So you can do things like pass it variables like current user is an object with the name, right? And now in the homepage, I can say, welcome back, current user.name.
Like
oh yeah, this way. With these special little tags here. I don't have there we go. Okay, so then you can see it says welcome back, Jared Grimm. So this is a tool for you to say, I got this big pile of HTML, and some of it's dynamic, right? If you're logged in, it's your name. If you're logged in, it's your name, right? So render is going to be doing this compilation step, okay? Sendfile is more like if we just had some static file. So if I had some static HTML file that I didn't need to change, it could stay the same way every time, right? I could come in here, and instead of rendering, I could say sendFile some static.html. Path must be absolute. And then it's going to send back that file. So sendFile is just going to look for a file. If it's there, it's going to read it, and it's just going to send that back. And I assume it's going to also call it HTML in its content type. Yeah, it's going to assume a text HTML content type. Or maybe it might actually be smart enough to be looking at the file extension. I honestly don't know. But that's the difference between sendFile and render.
So use sendFile if there's like some page you want people to go to like every time. It's like the first page that doesn't take user in, like that doesn't, you know, require people to be logged in. Like if you just want the same page every time.
Yeah, honestly, most apps we're going to use templating, and it's not that much overhead, and we'll just template every time. And so, like, you know, the curriculum app works this way. Every time you load the page, I go through a pug template, and maybe we probably could make some of those pages static files, and it'd be a little bit of an optimization, but honestly, just run everything through render and run everything to templates. And then if you really, really need that little extra bit of optimization where you don't want to pay the cost of running a little template thing, then you can use sendFile. The only other case that I found to use sendFile, which is sort of certainly outside of the scope of phase 1 and phase 2 content, but sometimes you want a web page where any GET request to like any path at all, you want to send the same thing, in which case that usually that can be static. Like you're just sending like a bootstrap. You're sending like, here's some HTML and JavaScript to just sort of get this single page app up and running. And I want that served every time you go to any page. We're serving the same thing. Then I've used that where I've made those, I've compiled those to static files and I've used sendFile. But honestly, render is gonna get you where you want to go, and just you're learning templates anyway, so just put everything in a template. Okay, cool, sweet.
7 minutes.
Well, I didn't get to routing, unfortunately. Is it quick? Your routing question?
Just like creating maybe an API. Whatever, like.
Okay, sure. Yeah, like the standard way to create an API is to create some sort of namespace in your URL schema. So if we're going to have an API, we're probably going to want all of our URLs to be something like get to /API/ let's say we're creating a library, right? So we want to get all the books. So we'll do a get to API/books. It's also sometimes we'll do a versioned API. So if we want to change it in the future. So we'll do get/books, and then we'll get book and the book ID, which would be something like the Dewey Decimal whatever of the book. And then let's say we also maybe want to like edit this book or delete this book. So these are RESTful routes that I'm dictating here just as an example of some API routes you might want to do. So if we were building a library API, we might want to put things, again, in this namespace. So there's a lot of tools that Express gives you to create namespaces. I think you can do... I think you can chain like that, where that will join these things together. So I think you can do some chaining like that, where so you don't have to repeat this every time. You also don't need to do that if you don't mind the verbosity. Then you can, obviously I'm omitting the callbacks here, if that wasn't obvious. You can just write your routes just like that. If you want to write your routes in another file, Express has like sub routers that you can create where you would, in some other file, you would say my API router is in Express, a new Express router. And then now this is, you can go like, you can do that. And then again, if you want to omit these things, we can set up your router to work like this. And then when we require that, we just do app.use and we give it a mount point. And we say, use this router here. So there's another way you can do it, is you can go off in another file and create a router that has all these routes and then import that router and mount it in your app at a specific location. And that one of the nice things about this approach is that this file, right, these things, which would be in another file, I'll indent it just to show that. These things don't need to know where you're mounted necessarily. They don't need to know you're at API v1 or API v2. They just export, I'm a API, and here's where you go, and then they can be sort of pushed under a namespace. So you could do that if that's something that you want. There's a lot of trade-offs here. Is that touching on what you wanted to know about?
Yeah.
Sweet. Any follow-up on that? You good? Sweet. All right, that's all the time we got today. Thanks, folks.
Thank you, Gary.
Thank you.
Thank you.